two parts, we are trying to generate the data that we are looking for. In this example, we would like to have 4 different groups of data points that form arcs with different radii. The range of the radii would be 2, 3, 4, and 5, as we have determined here. Generating these arcs are very simple and easy since we would be using the formula of the perimeter of the circle. As you can see here, by having the domain of the points, one of the coordinates of the points that we would like to draw or plot, we can use the formula of the perimeter of the circle here by having r as the radius of the circle and I as one of the coordinates in order to get the second coordinate here. And by having both of the coordinates, we would be able to draw and plot the scatter plot of the data points that we were looking for. And you can see that we have got 4 different arcs with 4 different radii here in this scatter plot. Here in this part of the code, we have defined a function called neighborhood. As you can see here, this function gets the whole data set, including the x and y coordinates, as capital X and capital Y, and a single point x and y coordinates. So these small x and y show the coordinates of a single point, not the whole data set. This min PTS shows the minimum distance or minimum radius that we consider to define a neighborhood of a single point. For example, if the minimum distance or the minimum radius is equal to 0.3, it simply means that around each point, each single point, this radius shows the neighborhood of that point. And according to DBSCAN, all those neighbors should have the same cluster label as the central point. This part is commented because it is simply the test, and it shows the code that we use to test the neighborhood function. So it is commented since the function proves to be working as we continue using it for DBSCAN, so there is no need to test it again. But if you want to separately test the neighborhood function to see if it works or not, you can uncomment these lines and run it. Here we have determined the minimum distance or the minimum radius for the neighborhoods to be equal to 0.3. We have reshaped all the x and y values on the arcs such that we would have a very long one-dimensional vector that contains all the data at once. In this case, we would have 800 points. We define the first cluster to be cluster number 1 and then start the process from then. We count the clusters from k equal to 1. And here you can see how we have reshaped the data set. We had 4 different arcs in which we had 200 points. So by reshaping them in order to have a very long one-dimensional vector, we would get 800 data points, all stored in a vector. In this part of the code, for each point, we call the neighborhood function to find its neighbors and give them the class label of each point. This is easy, but we should keep in mind that there are conditions that need to be considered in our code. So here you can see how we have called the neighborhood function each time for each one of the data points, each one of those 800 different data points. And as I said, we should consider different cases and different conditions here. For the points that are not the first point, if they are not already assigned a class label, we should check to see if they actually have any neighbors or not. If not, they are considered each time for each layers. And we have assigned a class label equal to 1000 to them to emphasize on their nature of being an outlier. Here you can see it. If they are not outliers, then we must increase the previous cluster label by the amount of 1 and assign this class number to its neighbors as well. This is what we have done with a series of if and else statements. You can see the results here. So this long list shows the results. It shows each one of the sample points is assigned to which cluster and the number of the neighbors that each point would have according to the minimum radius that we have considered for the definition of the neighborhood of a single point. Here you can see the labels, and these 1000s show the outliers each time. 1, 2, 3, and 4 shows the 4 different clusters that we would get. And you can actually change the minimum radius in order to have more clusters and outliers. By changing that minimum radius, we are changing the range of the neighbors that we are considering. So we can increase or decrease the number of the clusters that we would get.